For those of you who don't know, I was a Christian for most of my life, and asking whether God created the world and the universe and everything that we know that exists, if that was even a question, it wasn't. I just believed it. I was taught it. And it's kind of like rooting for your own football team or your own biased position because you were raised that way. That's kind of where I came from. I didn't even like Lawrence Krauss, to be honest, as a Christian because he was poking against my sensitive, comfortable religion. Well, in this show, he joins me on MythVision podcast, and he shows us scientific reasons for why a universe coming out of nothing isn't crazy. It's not a miraculous thing, and it doesn't require God. In fact, God would be an ad hoc proposition. Let me know what you guys think of this show, and make sure you subscribe, like, check out the Patreon, because this is being released early. We are MythVision. Welcome back to MythVision podcast. Derek Lambert, your host. Guys, look who's on the screen. I mean, I got Professor Lawrence Krauss. So I want to start with a little poetic intro here. Since the dawn of man, our universe and its origins have remained a mystery, even though theologians and philosophers have drawn conclusions on its origins, but advancements in science could solve the mystery of the universe's origins and its demise. The religious have often used God of the gaps arguments to deduce something created us. Is it possible that we are now able to understand scientifically how all this came to be by natural means? And this is where we introduce, today, we have theoretical physicist and cosmologist Lawrence Krauss, who's the author of the book we're going to be poking into today called A Universe from Nothing, Why There Is Something Rather Than Nothing. Professor Krauss is an advocate for public understanding of science, public policy based on sound empirical data, scientific skepticism, and science education. And he's an anti-theist. I used to not like him. This is a confession up front. When I was a Christian, I did not like him. But he seeks to reduce the influence of what he regards as superstition and religious dogma in popular culture. And I commend you for that. And thank you for joining me on MythVision.
Well, it's nice to be with you virtually. I should say I've evolved from being an anti-theist to being an apatheist because I really don't care. Because God's irrelevant to everything I do, so that never enters into the discussions. And 40 some odd years being a professor of physics and astronomy, I never heard the word while I was working in physics. And so it's not that I'm anti-God; it's just that God is irrelevant.
Interesting. That's kind of the point of having you on the show today, is to talk about this thing that you didn't really talk about often, but I think it'll be interesting too, obviously, to hear the science behind what you're going to say. I really appreciate you joining me. I want to give a thanks to Anthony Guthrie, my really good friend, for sending the donation to make this possible. You're the reason that the show is happening. So thank you, Anthony. And we're going to learn a lot today. So that's my small talk. And I saw a wonderful interview that I had to mimic some of the questions, but I feel like we're going to take this in a different direction. How did people respond to your book when you initially put this one out, A Universe from Nothing, Why There's Something Rather Than Nothing? And when you first published it, did people love it, hate it? Is this because your research destroys the last bastion of God, as I've heard you say?
Well, look, I mean, there were a lot of different reactions. But I was surprised at the popularity. It became a New York Times bestseller in the first week, actually, that surprised me. One always hopes for those kind of things, but I was surprised that happened. And I think the point is that people had been waiting for a long time for an argument. I mean, it is, and I don't know if Richard Dawkins said this or I did, but it is the last bastion of religion. I mean, for a long time, religious arguments, said, well, the existence of life is evidence of God, but then evolution demonstrated the diversity of life could come by natural means. And so the last question that seemed hard to answer is, how do you get this universe of 100 billion galaxies, each containing 100 billion stars, from nothing? Clearly, you need some supernatural shenanigans. And the remarkable thing is you don't, and I think that's certainly worth celebrating. And the fact, I don't write books, and I don't generally do arguments to try and argue against pseudoscience. I think it's important to do that, but I really try and get people excited about the real universe, because that's so much more interesting than the myth and superstition. And so I wrote that book to describe the amazing revolutions that have taken place in cosmology in the last 50 years, and to get people excited about those. But a corollary of that is that that we now have a plausible mechanism to understand how you could get a universe of 100 billion galaxies, each containing 100 billion stars, from nothing, with no supernatural shenanigans. In fact, the really remarkable point is that if you asked, what would a universe created from nothing by physical laws, quantum mechanics, etc., that lasted 4 billion years look like? And the answer is it would look virtually identical to the universe in which we live. Now, that doesn't prove it, but it certainly makes it plausible. And that's remarkable. And it's remarkable for a variety of reasons, because 30 or 40 years ago, we couldn't even ask that question. It would have seemed like a non-scientific question. And the answer is, now we have a whole series of steps in cosmology, discoveries that have changed the way we think about the universe, as well as theoretical arguments that make it plausible. And I think that's remarkable.
Well said. Yeah, there's a bunch that we're going to be talking about today that's probably going to be over your head. It was over my head. Your book was something else, I have to admit. Like, I could keep up to you, like with you up to a certain point. Then I was like, I need a visual on this. I'm like, this is...
Well, it's a short, it's a short book. I think science books should be short, and it's a short book. I wanted to do it in the minimal amount of space to take people through who wanted to puzzle through. But it is complicated stuff, and it's it's at the forefront of physics. It actually began, I think you told me beforehand that not only did you not like me, but you didn't like Richard Dawkins.
Yeah, he was tough.
And the book began, really what happened was Richard asked me to give a talk at a convention. I think it was the Atheist convention in, I think 2009. I can't remember what year, maybe 2008. And he asked me to do this, and I had a few days notice, and I just sort of I put together this lecture, and it was kind of last minute, and I put it together on the fly. And I may have even called the lecture Universe from Nothing, but it created a huge stir, and there were like several million people that watched it afterwards. It was where I made up, most of the jokes I do are invented on the spur of the moment, but I was talking to that crowd, and that's when I was talking about how every atom inside your body comes from a star, and I uttered these words, which are now I see on mugs and other things, where I said, forget Jesus, the stars died so you could be born.
Oh, that was so good. I've seen that. Yeah.
Yeah, and it was just off the cuff, but in any case, so that was popular enough that I thought, well, maybe this will resonate with people. Of course, there were the groups that immediately, the haters take more time often. Some haters do it immediately, but they take more time to develop their arguments. And I made a joke in the early part of the book just for a joke, but of course it alienated a variety of theologians and philosophers, because I said theologians and philosophers won't like my definitions of nothing, maybe, but they're experts at nothing.
Oh.
And anyway, so that got their hackles up. And of course, what you read are ridiculous arguments from people who've actually not read the book, but argue that what I'm talking about is not really nothing. But of course, they never define what their really nothing is, which is their main point. The Bible doesn't really define the void, right? Generally, the void of the Bible is this infinite, vast, empty space, right? The void. And that's one kind of nothing, but I'm actually pretty careful in my book to talk about different kinds of nothing. But there are people who say, well, he's not talking about a universe of nothing, he's talking about a quantum vacuum. And most of them don't even know, they know how to say those two words, but they don't know what quantum or vacuum means.
I honestly don't either.
Well, no, it's a complicated subject. And the point is, I'm not even saying that. I'm talking about the universe, everything we see that exists now, space, time, and everything within it, in our universe, did not exist. Now, if one has the laws of quantum mechanics, you can pop a whole space-time into existence where there was none before. So the question, of course, that's begged is, well, did anything else exist? Were there other universes? And that that's a metaphysical question, and to some extent one you can address in science, but it's irrelevant. The point is that our universe didn't exist and then came into existence. Now, any semantic babbling that these people come up with arguing about a quantum vacuum means they haven't understood the central point, that there literally was no space, no time, no stuff. Literally everything that we see did not exist. And I don't care if anything else existed, because that's not the question. The question is, can you get our universe from nothing? And it literally is nothing. Now, it is true that in order to, there are a few things I should qualify. First of all, we don't have a full theory of quantum gravity. So we can't calculate the mechanism by which our universe could have evolved from nothing. It's just by extrapolating what we now know. In empty space, quantum mechanics and special relativity tell you that particles can burp in and out of existence all the time, and are doing it all the time. Then if gravity is a quantum theory, which there's no reason to suggest it isn't, quantum mechanics looks like it's fundamental to our universe, then space and time, which are the variables of gravity, become quantum mechanical objects. And if they're quantum mechanical objects, then space and times can pop in and out of existence. That's all we need to know to make it plausible.
So if I may, this is interesting because I wrote this down, but this is down on my notes a little, and we're already getting into the deep water, and I'm like, whoa. I love this, by the way. Thank you for this. One of the things that I was thinking about with Richard Dawkins being a biology expert on this, and Abiogenesis, if you will, like the fact that like different elements combined under the right circumstances in some way, we believe that this is how life began. How it happened in the correct environment and exactly how, that's the complex part we aren't really able to exactly reenact. But does that translate somewhat into what you're saying here about the universe, is that there's something here, we know we have the components, we have the idea, we just can't there's a picture of it, look, it just happened, and we don't have the evidence of it actually taking place?
We don't have the full theory yet, but Richard made more of an analogy. It's kind of pompous to me to suggest that this argument was the same as Darwin's argument, but his was profound. But and he spent years validating the data. But the idea is very similar. When Darwin came up with the idea of evolution and came up with all sorts of evidence from looking at fossils and looking at existing species, he didn't know about DNA. He didn't know the mechanism of genetic replication and mutation. He didn't know any of that. He just said, look, it's plausible. If I look at these things and I can demonstrate that there's real good evidence for evolution of diversity, I don't know the mechanism of that evolution. And in some sense, it's the same. All the evidence points to a universe from nothing, although we don't know the specific evidence by which it came into being. And by the way, and that's important about evolution too, evolution, natural selection, explains the diversity of life from a common ancestor, but it doesn't explain the origin of the common ancestor. That we still don't have a full theory of. We have lots of arguments suggesting it's plausible, and all the time people are arguing for ways that natural mechanisms on Earth, in deep ocean, or in layers of various crystal layers, that you could develop a separate replicating object with a membrane and etc. But we don't know. We don't have those exact steps yet. I suspect in the next 25 years we will, but we don't have that. But there's no evidence to suggest it's impossible, and in fact, every bit of evidence to suggest it's likely. And it's in that sense, the beginning of life and the beginning of the universe are on the same footing, in the sense that we have a plausible mechanisms, but we don't know the details yet.
This is fascinating. I mean, I never thought I'd even be asking these questions. I was like, God did it, and that's enough for me.
That's the argument for people who want to stop thinking. Basically, it's just, if it seems so puzzling, just say God did it, and then you stop thinking. And the point is that that's too often been the history of many ideas, is that people say, well, look, I can't possibly understand how that could happen. I have no idea how that can happen, so therefore God did it. It's like the people who say, I see something in the sky and I don't know what it is, so it must be aliens. I mean, there's lots of other possible explanations, and in that case, aliens are the least likely possibility, and I would argue in the case of God, generally God is the least likely possibility. And of course, that argument, as you know, is subject to is called the God of the gaps argument, which is to put God when we don't understand something, because the problem with that is every time we understand something, the gap becomes smaller and smaller, and
they shift God. They shift,
and I think my argument, in some sense, closes that gap more or less completely. I mean, it doesn't. There are these questions about was there anything before? Did time exist before? Is it infinite in the past, infinite in the future? These are interesting, potentially interesting philosophical questions, and to some extent, sometimes physical questions. Right now, they're metaphysical. And you can bury God in that realm. But the point is, if you're doing that, that's fine. But it just makes God more relevant. It literally, as I was not being facetious at the beginning of the program when I said that it's never discussed. You don't need God to understand anything that we can see in our universe. That doesn't make the existence of God impossible. It just means it's redundant. It's an idea that unnecessary. And so, yeah, if it makes you feel good, fine. But God doesn't add anything to our understanding of anything.
Professor Krauss, I have a hard time, because I don't know the science as you do, trying to figure out how, when we talk about quantum mechanics and things popping in and out of existence, and we could see that happens, like...
Well, we know it happens. We can't see it happen directly. We can infer that it happens. But anyway.
My question is like, when I look at material matter, right? I live in such an equilibrium. I'm just, everything's good. Life's great. Like, how come everything goes just the way I like it? Sun rises, the sunset, my question is, where does all this...
like Bill O'Reilly, sun rises, sunsets, no one understands it. I mean, yeah. Anyway, sorry, go on. Go on.
Well, how does material, I guess I have a very, very limited understanding on the science here.
Sure.
But how can nothing, in the way you're defining this, produce actual material, mass objects of Earths and planets and stuff like that? You know what I mean?
Well, it's a subtle idea that, in fact, the point is that, virtual particles and antiparticles are popping in and out of existence all the time, but they have to disappear because they violate if you could measure them, they'd violate what's called the conservation of energy. If you have nothing and then you have particles, you appear to violate the conservation of energy. The great thing about gravity is, when you include gravity into the works, you can have positive energy and negative energy. Gravitational potential energy, if you wish, is negative. And the reason for that is that if I have an object out at infinity, actually it's Carl Sagan here.
Oh, wow.
Anyway, if I have an object out at infinity at rest, it's reasonable to say it has zero energy, right? But then if it falls towards a planet, it loses energy, right? It loses potential energy as it falls towards the planet, and therefore its gravitational energy here is less than it was there, and if it was zero there, it's negative here. And once you allow for negative energy as well as positive energy, then you see you could actually create a system where you create two particles, say, particle-antiparticle pair, and their rest mass has energy, but there's a gravitational attraction. So the potential energy, the gravitational attraction, is so negative that it overcomes the positive energy of the mass, and the total system has zero total energy. And then it can come in. Then those particles can persist. They can exist in real life because their popping into existence doesn't violate any rules of conservation of energy. And so, literally, the vacuum can burp particles eventually if there's sufficient, say, gravitational forces, and that happens near a black hole, for example. Particles, antiparticle pairs pop out into existence near the source of a black hole, and the antiparticle can fall in, say, and lose enough energy that the particle can be radiated, and that's what we call Hawking radiation, and black holes radiate. And so the point is, because of the negative energy that's allowed by gravity, you can create. It's like a friend of mine, an eminent physicist named Alan Guth, once said, it's sort of the ultimate free lunch. Because of the fact that gravity can involve not just negative energy, but also negative pressure, you can have a phenomena which was first described by Guth. It's called inflation, where you can have a small universe inflate and become very large and dump a lot, at the end of that, dump a lot of energy into space. And all of that is due to the negative pressure of expanding space. And he called it the ultimate free lunch, because apparently you start with almost nothing and you end up with a universe with lots of energy. And that idea was very influential to me when I was talking about the whole universe creating from nothing. It's really just that gravity adds a new complexity to the mix and allows for phenomena which are not intuitive in any sense, because we don't see, all objects that we see, mass is gravitationally attractive. It's got positive energy. We're used to gravity always pulling, and never pushing, and sucking and never blowing, depending on how you want to think of it. But it turns out, once you allow for general relativity, exotic configurations of mass and energy can exist that have strange properties and change all the rules. And that's just the way it is in physics. We discover the universe is stranger than we thought it was, and the rules change. And some people don't like that. They say, no, you're not allowed to change the rules. But actually, discovering the rules are different is what we call learning. It's something theologians don't know about. It's called learning. And theology has never learned anything. There's no contribution to knowledge in the knowledge base of humanity from theology in the last 500 years. And I say that not in a biased sense. I've asked theologians. I've been with theologians, and I challenge them. I say, give me one contribution to knowledge that theology has made since the scientific revolution in the last 500 years. And they all say the same thing. What do you mean by knowledge? And I would submit that if you asked a physicist or a chemist or a biologist or a psychologist or what contributions to knowledge they made, their fields have made, they wouldn't say, what do you mean by knowledge? They'd give you an example. And I think they're driven to that because they don't have examples. And that's really important. The fact that religion has all the answers before you even ask the questions means that you can't possibly add to knowledge, because they don't, the answer is always God did it. And that's not an answer to knowledge.
It's interesting too. Like, I recently interviewed, well, let me mention this. Do you know Tim Minchin?
Yeah, he's a friend of mine. Yeah, I know Tim. Did you interview Tim?
No, not yet. I'd love to. I plan on trying.
He's a neat guy. Yeah.
He's hilarious.
I'm going to have him on my podcast. So there you go. Anyway.
Well, you'll probably beat me to the punch. So,
okay.
No, but I'd love to definitely interview him. I loved his Thank You God video. And he's talking about the mom who's, she had cataracts. And he's like, it couldn't be misdiagnosis. It couldn't be all these other things. I thought he's brilliant. He really is.
Brilliant. He's great. Tim Minchin, I'm a huge fan of his, and I'm fortunate to know him. Yeah.
That's awesome. So I interviewed Professor Mark Solms, who's actually a guy who wrote a book called The Hidden Spring, trying to find out where consciousness comes from. And I don't think he means that in a philosophical way. He means this in a neuroscience way of trying to understand.
And we still don't know the answer. It's a big open question.
It is. But he talks about homeostasis and how it works within us. And there seems to be this, there's this certain place where pleasure and pain, where we're in between it and we survive this way. I wonder if the universe has somewhat of a form of a homeostasis existence with a zero energy here. It's like you mentioned, if I'm not mistaken, in previous interviews, it's zero energy, but there's maybe you can describe this mathematics. There's like a 30% something of
well, the total energy of the universe, we think as we measure it, seems to be precisely zero. Energy is not well defined in general relativity, I should say that, but the classical Newtonian energy appears to be zero, but that doesn't mean there's nothing that has energy in it. It says there's a balance of things, and so the universe as we measure it is spatially flat, which is another way of saying it has zero total classical energy. The universe we measured spatially flat. Doesn't mean it's like a piece of paper. That's a two-dimensional flat universe.
You get that all the time.
Yeah. A three-dimensional flat universe is just one that the universe you always thought you live in, where the x, y, and z axes are perpendicular to each other and point in the same direction in all of space. In a curved universe, the x, y, z axes can point here in one place, and then when you're over here, they point in a different direction. That's because space is curved. But in a flat universe, everywhere you go, they point in the same direction. That's all. It's the universe we always thought we lived in. But we can measure that. We can measure looking for curvature of space, and on large scales, it appears it's not curved. And so the universe is flat, but in order to make it flat, gravitationally, you have to have a certain amount of energy. And we used to think that there was enough matter to make the universe flat. And when I was first studying dark matter, when I was a young researcher and assistant professor, and one of my big research areas was to look at this dark matter, which is, when we look at our galaxy and all galaxies, most of the mass of those galaxies can't be attributed by stars, can't be attributed to stars or even hot gas. It's something that's invisible. It doesn't shine. And we call that dark matter, and it's true. And they are dominated by dark matter, and we can measure that amount of material by measuring the gravitational attraction of things and the way light bends and all sorts of ways. We're convinced that there's probably 5 to 10 times more stuff out there than meets the eye, and it's probably, in fact, the strong arguments that suggest it's a new type of elementary particle, which is why I got involved in the game as an elementary particle physicist, with, proposing dark matter particles and experiments to look for it, etc. So we thought, okay, well, that's it. There's enough dark matter to make the universe flat. But then it became clearer and clearer the more we measured that there wasn't enough dark matter. There's only 30% of the amount of stuff needed to make the universe flat. And in fact, in 1995, a colleague of mine from the University of Chicago and I wrote a paper saying it doesn't work. There's not enough dark matter to make the universe flat, and there's all these different tests you can do, and looking at all the observations, the only way you could have a flat universe is if 70% of the energy in the universe resided in empty space. If empty space itself had energy. Now, at the time we proposed that, we didn't believe it. My own feeling was it meant that some of the observations were wrong, and it was a way to demonstrate that the observations were wrong. But in fact, it turned out to be exactly right. 70% of the energy of the universe resides in empty space. And the way you could test that is if you put the energy in empty space, it's gravitationally repulsive. If you put energy in empty space, it blows, it doesn't suck. And that causes the expansion of the universe to speed up faster and faster and faster. And in 2008 and 2009, two sets of astronomers were measuring the expansion rate of the universe and discovered it was speeding up. And the amount by which it was speeding up was precisely the amount we said was necessary to be in empty space. And they won the Nobel Prize for that discovery.
It's also interesting, that the way to test this, they go deep in the earth to try and keep radiation from coming through, correct?
Oh, that's for dark matter. Yeah. So dark energy you measure by looking at the expansion of the universe, the energy in space. Dark matter, we think it's a new type of elementary particle that doesn't really interact strongly, doesn't interact with light. And how can you detect it? Well, if it's out there, it's also in this room. It's also in your studio. It's going right through your body as we have our discussion. It does interact so weakly, most of it goes right through the earth without knowing the earth was there. But some of it will interact. And the point is, it interacts so weakly that if you put a dark matter detector here where I'm sitting, there's so many cosmic rays that they would overwhelm the signal. But if you put the detectors deep underground, where they're shielded by miles of rock, then the cosmic ray particles get stopped and the dark matter particles will make it all the way through. And every now and then, one of them might bounce and it be detected in a detector. None have been detected yet, but we're building larger and larger dark matter detectors to look for it. And I'm part of an experimental collaboration that's trying to do just that.
Oh my goodness. So you mentioned the expansion of the universe, right? I came from the theologian side, the kind that hasn't contributed in the last 500 years. Yeah. I'm trying to contribute now, but I have to say we had what we call eschatology, and it was Jesus is going to fly back on a horse, or who knows, whatever picture you have, on a cloud, and
Muhammad.
Every religion has this strange eschatology, the end. But you have a real concrete vision. And is it a doomsday vision?
I've written about the future of the universe, and the answer is it's not going to. It's pretty bad in the long run. It's not going to end well, at least in terms of what people, what you might think it would be. And as I think I told you beforehand, I wrote a bunch of papers on the long-term future of the universe, and discovered I was doing eschatology at the time. I'd never heard of the word. And the point is that ultimately, because the expansion of the universe is speeding up, it's carrying away distant galaxies with it. Space is literally carrying those distant galaxies away with it. And eventually they'll be moving away from us faster than light. It's allowed in general relativity, it turns out. Because they're not moving through space faster than light. That's not allowed. But space can do whatever the hell it wants, and it can expand away from us faster than light. And eventually they'll become invisible. And we calculated that in about 2 trillion years, all the galaxies outside of our own galaxy or the galaxies that are bound to our galaxy will have disappeared. And astronomers, there'll still be stars around. So life forms that evolve around stars in what will then be a massive galaxy, because it won't be our Milky Way, because our Milky Way would have collided with Andromeda and a bunch of other galaxies. It'll be a big galaxy. Any civilizations that develop around those stars will develop astronomy and build telescopes and look out, and they'll actually think they live in the universe we thought we lived in 100 years ago, because they won't. In 1925, we thought there was one galaxy in the universe, our Milky Way galaxy, and the rest of it was empty space, static and eternal. And those astronomers will look out and see nothing outside of their galaxy. All evidence of the rest of the expansion of the universe and the rest of the universe will have disappeared. But then, if you wait a longer time, those stars will die out, actually probably merge to form black holes, and then the black holes will evaporate, and there'll literally be nothing. The universe will be cold, dark, and empty, and that's the future of the universe. It's cold, dark, and empty. So it may have begun with a bang, but it'll end with a whimper, and that's the future. And the interesting thing is, actually, since you mentioned eschatology, it is an amusing story that I haven't told very often. I was invited to a meeting at the Vatican, of all places. I don't know how many, maybe almost 20 years ago, at the Pontifical Academy in the Vatican, to discuss basically the future of the universe as seen by physicists, biologists, and theologians. And it was held in the Pontifical Academy where Galileo was kind of excommunicated, and it was quite a fancy thing to be in. And
wow.
And I stayed in the Vatican, in one of the hotels in the Vatican itself, right next to the big St. Peter's, it wasn't amazing. Unfortunately, it was the day that I was there during the election. It was in 2000. I can remember now, because I was watching TV in my little room in the Vatican when Al Gore won the election, and then I went to bed, and then I woke up, to catch a plane, and discovered that apparently he hadn't won, and it was it was weird. But anyway,
wow.
But the thing that's an aside. The thing that was interesting at that meeting was a total failure, because we talked past one another. Because for the theologians, the far future was the resurrection, and they were thinking thousands of years, or who knows. But for the physicists, the far future is trillions of years in the future, because we know that that there's no evidence the universe is going to collapse in any time scale shorter than that. And so we just had nothing to say with one another, which was my first evidence that really we did have nothing to say with one another. And as I told the theologians there, and I was quite blunt about it, I said the difference between my lecturing to you and you lecturing to me is that you have to listen to me and I don't have to listen to you. The reason being, if you want to be a sensible, quote-unquote, theologian, you have to know what the evidence of reality is, and you have to try and work your myths around that reality. But as a physicist, I don't have to know anything about your myths. So literally, they had to try, and the reason they had the meeting, it was, the Vatican has a Pontifical Academy, which is scientists who advise. And the point is, they need to know what the current science is so they can manipulate their stories to be consistent with the science. They eventually had to decide retroactively that indeed the Earth wasn't the center of the universe, or even our solar system.
It's a hard one to swallow.
They got burned with Galileo, and so they've tried to keep up with the science ever since. So they have to listen to the scientists. But the scientists don't have to listen to the theologians because they have nothing to add. So it was interesting that when I was at this meeting, which was literally an eschatology meeting at the Vatican, we had nothing to say to one another.
It's interesting. Do you feel the same way about philosophers often? I mean, it sounds like they're in the same vein. A lot of times it's word fluff, and it's non-dualism, or something that is esoteric explanation for reality, or this is all consciousness. You said on a previous interview that, because the person mentioned, we're going to talk about reality, we're back in reality. And you're like, no, physics is reality. Can you explain this, of what you mean and how that differs?
Well, I don't mean physics. I mean nature. I mean the world as we empirically measure it. There is nothing else, right? I mean, no knowledge comes by revelation. It all comes from empirical evidence and you're seeing how the world works. And that's it. And that's the basis of all knowledge. When you say philosophers, I mean, the point is it depends on the philosopher you're talking to.
Right.
There's some who just babble words, semantics. But, there are lots of philosophers who try and the philosophy is really we all do philosophy, but philosophy is a rigorous philosophy is a method of analysis and critical analysis and logical analysis to probe interesting questions. And in fields of science where those questions are not well defined, like say consciousness, philosophy can be quite important because it can frame the important questions. And there are philosophers like Dan Dennett, who's really heavily involved in relating to neuroscience. And that was true early on in physics when the questions were ill-defined, and philosophy was called natural philosophy after all. And it was important for setting the stage to the kind of questions that would be relevant to driving the field. But once the field began to mature more, the important questions to physicists are not the ones that philosophers ask. And in order to ask the important questions, you have to have a lot of intellectual baggage. You have to know in order to know what the next interesting thing is, you have to know all the stuff that we now know. So it becomes physicists who are asking the questions, and philosophy really has no impact on physics nowadays. That doesn't mean it's unimportant. It just has no impact.
Right.
And philosophers of science, there are philosophers of science, and they do serious work, but it doesn't, and it may be laudable work, but it doesn't impact on the development of physics itself.
That was what I was going to ask is, I guess, in the vein of this, what does physics do that philosophy cannot do? And I mean, that pretty much is the testing of... When it comes to physical questions, absolutely nothing. It can do a lot more, and it does a lot more. That's why physics has progressed, and the philosophy of science really hasn't done much. But when it comes to non-physical questions like consciousness, which maybe ultimately is a physics question, but it's so complicated it's going to be studied by neuroscientists. Right.
Physics doesn't have much to say at this point. Some people think it does. My friend Roger Penrose thinks somehow physics is related to consciousness. I think he's wrong. But we'll find that out. But right now, what physics doesn't do is produce interesting questions about consciousness that philosophers can at least frame. So there's some room left for them. Let me put it that way.
This is really interesting because I was interviewing Professor Mark Solms in his book, and he seems to have somewhat of a quantum mechanic angle of trying to explain, I think, look, some of his stuff went over my head in his book. Yeah. So it's really, really fascinating. So I really appreciate you going into this and explaining. So this is the next question I'd like to pose to you, if you don't mind.
Sure.
What alternate explanation are there scientifically for the existence of the universe? Like, I know there's more than one that could potentially make sense. Like, for example, some people say that the universe's origin, the Big Bang, is actually the end of a previous, right? It's a theory.
Oh, yeah.
Or a hypothesis, if you will, but we don't have evidence prior to that because we can't empirically observe or test in any way. It's metaphysical. But are there any other metaphysical explanations to you that are just as plausible that don't require...
There are more plausible ones than that. That's very implausible based on everything we know. But the point is that, as I said, t = 0 is an open question right now. And so was there a time before the universe? Well, Stephen Hawking would say, and I would tend to agree, that it might be a bad question. Because if space began, so did time. And there literally may be no time before the Big Bang. So you can't even ask the question, what was before? It's not a good question. That's frustrating, but that's just the way it is. But that may not be the case. You're right. It could have been an infinite cycle of collapse and expansion. There's no evidence for it. There's no good theory. There are people who promote that idea, but it's really not generally. Most physicists think it's ugly and not well defined. But the best.
What convinces
argument,
you
the best,
most?
The best metaphysical argument for our universe comes from inflation. And it's for the origin of a multiverse. It's not really for the origins of our universe, but I'll explain it. So early on, let's say you have a Big Bang, and early on, the energy of space begins to dominate over everything else, and the universe begins to expand very, very fast. And then there are local pockets where there's like a seed forms, like a raindrop, where you decouple from that background expansion, and a local hot Big Bang develops. All that energy of empty space gets dumped into matter and radiation, and it's the beginning of what essentially is the beginning of a Big Bang. Our Big Bang. but that means our universe sort of formed. But that means that means there's much more space outside of our universe, which is still expanding exponentially fast. And there could be other universes forming now, and other universes collapsing now, and it could be infinite in time. That process could have gone on infinitely, and there could be an infinite number of universes, and they're all way beyond the region we'll ever be able to see, because they're expanding in a space that's expanding exponentially fast. So the universes are being dragged apart faster than you'll ever be able to measure. And so most of us think that it's most likely that we live in what's called a multiverse, which is, namely, our universe is not all there is. There's other potential universes in which even the laws of physics could be different. Because what I didn't get to say early on is that the one presumption that it's simple to make, the one presumption that makes it easiest to understand a universe from nothing is to assume that quantum mechanics, in some sense pre-exist our universe, that the laws of physics were fixed and our universe arose in them. But people say, well, if you have the laws, then that's nothing. And my answer to that is, well, you don't necessarily need the laws. It could be that the laws come into existence when the universe comes into existence, and the other universes can come into existence with different laws of physics. And that we don't know. That's really metaphysics, but it's certainly a possibility. But it's quite possible that in these other universes in the multiverse, there are other laws of physics, that particles have different masses, that there are different forces. All of that is possible, and I think that's the best sort of metaphysical picture of if you want, our universe's origin. But we don't. But anything we say about t equals 0 at the exact beginning is pure speculation. It's metaphysics. You can call that philosophy if you want, but we don't have any evidence to sort of refute it, and therefore right now it's fine to talk about, but it's just talk.
How does this differ from string theory?
Well, string theory purports to be a theory of quantum gravity, and a theory of space and time, and string theory requires, at this point, apparently more than 4 dimensions, maybe 10 or 11, although it's not really well defined, and the whole theory isn't well defined. But if it is ultimately a theory of quantum gravity, and it could be, then it could explain specifically how the mechanism by which space, if you want to call it that, comes into existence. But right now it's a very poorly understood is a better way than poorly defined, poorly understood idea. It's really got a lot of features that make it attractive to physicists, but it hasn't yet explained anything about our universe or the origin of our universe. It has the potential to do that, and maybe one day it will, but there's no evidence that it has yet.
This is fascinating. I have to ask a good question for my friend, Dr. Joshua Bowen, and he gets this a lot. So we're going to pose it to you. And this is a theoretical physicist we're talking to. So you're one of the leading guys out there. We often hear people who argue for the existence of God through presuppositional apologetics. I'm sure you've engaged with people like this. They pose questions like this. If you remove God from your worldview, what takes his place? And then this is really the pose to you, and I'd like you to give your honest response on you.
Well,
I was going to say that real quick. I just want to finish this. What is the foundation, the ultimate fundamental non-dependent source of existence that institutes and secures all possibilities and impossibilities? How would you address a question like this?
Well, the point is you don't need such a thing. Why do you need such a thing? You don't need a purposeful source. Things can just come into existence.
Right.
As I often say, the lights, I've got studio lights on here, and the photons are being emitted by the atoms in the light bulbs. Didn't exist before they were emitted, right? They didn't exist. They didn't need some god to say, okay, come on out now. And it was just laws of nature. And so the nature can have, laws without anyone. The presumption that you require some intelligent entity to create that is just a human anachronism. You don't really need. So the point is, what replaces God? The answer is you don't need anything to replace God. There's no need for God in the equation anywhere. And in fact, actually, when I think about it, I did the Colbert Report years ago, and it was when the Universe of Nothing first came out, and we had fun. And he said, so you say God literally is nothing. Is not there's no thing that's God. And I say, yeah. And he said, well, if God is nothing, can't the universe come from him? It was his joke. And, and I think, okay, if that makes you happy, fine.
That is so good. That was a really clever statement.
He's very clever. He's very clever.
It is funny, though. You're right. And I think it is. And I'm actually interviewing Dr. Michael Shermer come Monday. We're going to be hanging out on his Believing Brain book. And that one blew my mind because all the mechanisms for why we believe are really discussed throughout his book. And we'll be going into that. I'll be mentioning you, of course, on the show. I promise I'll tell him not to say anything bad. I know. Now I'm just teasing. Y'all are good friends.
Tell him say hi. Yeah.
I know. Y'all are close friends. So there's someone out there. This is how I always like to end things. We're going to eschatology this show and hopefully on a good bang here. And you're talking to someone who is wanting to be more scientific minded. They're struggling with the emotions that you understand the psychological, I'll use the word damage, but I'll say the psychological baggage that comes with these superstitions that we have. Your goal is to get people to think more empirically and to start observing the facts. What would be your encouragement to the person right now who's afraid to let go of this concept of God, kind of like when you're a kid, you have an invisible friend, or it's like a mommy and daddy, they're praising in church, their hands are up high, like, pick me up, daddy. That's really what they're doing psychologically. What would you say to the person who wants to take what you're saying, but they're afraid? They're afraid of the repercussions and hell and...
Sure. The first thing I would say is that we already use the language incorrectly. We talk about a loss of faith as if losing faith is a loss. And in fact, it's not. It can be a great gain. Because if you give up this notion that it's impossible to understand reality and begin to ask questions about nature, you gain a lot. You don't lose anything. And the real thing that I'd say is that the real universe is so fascinating, you don't need the fairy tales. It's awe-inspiring to look out at a Hubble Space Telescope picture and realize the amazing universe, and to think how fortunate we are to have evolved in such a universe for a short time, to have a consciousness where we can ask such questions. So instead of being worried, you'd enjoy your brief moment in the sun. Enjoy the fact that we're here as a cosmic accident. Does not make life purposeless. It means we make our own purpose. And it makes every instant we're alive more precious. Enjoy and exploit the brain you've been given and experience the universe in its totality. Learn about it. Enjoy it. It's fascinating. It's wonderful. It's pleasing. And enjoy the experience of being human, the opportunity to love others, to get to know other people, to communicate, to look out. Isn't it amazing that we here on this remote planet in the middle of nowhere can look out with our telescopes and have developed ideas that allow us to understand the evolution of the universe back to almost the beginning? Celebrate existence, and really celebrating existence is what reality is all about. And you don't need fairy tales to do that. Wow,
well said. I couldn't have said it better myself. Ladies and gentlemen, make sure you guys go and check out, where's it at? Right here. Get his books. He's got his books on Amazon. I have the link down in the description. I really ask you guys to go check out his material. The book that I was reading was A Universe from Nothing right here.
And beside it is hold on. Okay,
sorry. Let me go back.
Go back. And beside it is my new book. So
this one
that just came out a few months ago, Physics of Climate Change.
Oh wow! I think he accidentally backed out, ladies and gentlemen. Let's see what happened here. Here he is. He literally popped in and out of existence just now. We have evidence. We have evidence now.
I was in that quantum vacuum for a while. Yeah.
I wonder how painful it was. Seriously, get the books. I'm actually going to check this one out next because I know some climate change deniers. And yeah, I need to read this because I'm interested in hearing what an actual scientist has to say about it. Plus, you have other stuff. The greatest story ever told. That sounds so interesting to me because theology is all about stories and we're a narrative type creature. So get his works and check out his website. He also has a podcast. If you guys aren't aware of it, make sure you go check out his podcast, the latest book. Here's the website. You guys can, I'm sure, sign up and get his weekly, or how does it work? You give emails out and stuff to notify people?
We generally announce when it's out. Yeah. I mean, the podcast is for our Patreon subscribers. They get a notice right away when there's every new one. But same for the YouTube subscribers, because it's a video podcast that comes out eventually on YouTube. And we have usually one new podcast a month because it requires a fair amount of production. But we also have a lot of things in between. I do some physics ones and stuff. So and we have some fascinating guests. So this last month was a filmmaker, Werner Herzog, for example, who's a well-known filmmaker, and we next month it'll be a Nobel Prize-winning physicist. And so we jump back and forth between science and culture. And we've had people from Ricky Gervais on to
I saw that. I saw that clip.
Yeah.
He's a funny guy. So how much is it to join your Patreon?
It's $5 a month. Well, actually, there's still a $2 a month option. But if you want to have, we also do a Q&A once a month, a live Q&A with me. And if you want to do that, it's $5 a month. But you can just get the videos for just $2 a month, which is pretty.
A coffee, I buy a Starbucks every day.
It's not even a coffee. 2 months is a coffee. Yeah.
You're right. Well, thank you so much, man. Let's do this again. I hope we can do this to promote what you're doing. I appreciate all the information. Please, I'd like to have you back.
Okay. Thanks. It was fun. Okay, you take care.
Ladies and gentlemen, we are MythVision.